Welcome, CI Activity 2 Self-Learning Video Making. The world is shrinking. There's a deep and relatively unexplored world beyond what the human eye can see. The microscopic world is truly alien and truly fascinating. I'm delving further than the microscopic scale. I'm going to explore the potentials of working in a nanoscopic level, working at a level of billion times smaller than the average scale we work at today. This is nanotechnology. Nanotechnology means any technology on a nanoscale that has application in the real world. Nanotechnology is the science of building small, and I mean really small. It's pretty difficult to imagine how small a nanometer is, but let's just take a moment to try and wrap our heads around it. The tip of pen is around a million nanometers wide, so nowhere near close a single sheet of paper is around 75,000 nanometers thick. A human hair is around 50,000 nanometers thick. Let's just take a different approach. If a nanometer was the size of a football, the coronavirus would be the size of an adult male, and a donut would be the size of New Zealand, and a chicken would be the size of Earth. In fact, on a comparative scale, if each person on Earth was the size of nanometer, every single person on the planet would fit into a single car. A Hot Wheel car. You get the idea that nano is super tiny. We are talking subatomic too. That's how big or rather small a nanometer is. But why does it matter? Why look at really small things? Well, they ultimately teach us about the universe that we live in, and we can do really interesting things with them. When we move into the nanoscale, we can work with new domains and physics that don't really apply at any other scale. Nanoscience and nanotechnology can be used to reshape the world around us. Literally everything on earth is made of atoms. The food we eat, the clothes we wear, the buildings and houses we live in, our own bodies. Now, think for a moment about how a car works. It's not only about having all right parts, they also need to be in the right place in order for the car to work properly. This seems obvious, right? Well, in pretty much the same way, how the different atoms in the something are arranged determines what pretty much anything around you does. With nanotechnology, it's possible to manipulate and take advantage of this, much like arranging Lego blocks to create a model airplane or spaceships. But there's a catch, and here's where things start to really get interesting. The properties of things also change when they are made smaller. Phenomenon based on quantum effects. The strange and sometimes counterintuitive behavior of atoms and subatomic particles, but her natural human matters manipulated and organized at the nanoscale. These so-called quantum effects dictate the behavior properties of particles, so we know that the properties of materials are the size dependent when working at the nanoscale. This means the scientists have the power to adjust and fine-tune material properties, and they have actually been able to do this for some time now. It's possible to change properties such as melting point, fluorescence, electrical conductivity, magnetic permeability, and chemical reactivity, to just name a few. Now let's see the method of synthesis of nanoparticles. For synthesis of nanoparticles classified as physical methods, biological methods, chemical methods. Physical method contains electrochemical, ultrasonication, laser ablation, irradiation, evaporation, condensation. Biological method contains green synthesis, plant, fungi, bacteria, algae, yeast, and actinomycetes. Chemical methods contain etching, mechanical milling, laser ablation, sputtering, thermal decomposition. Now let's see synthesis of nanoparticles by colloidal route. A colloid is a mixture containing dispersed particles with dimensions of approximately 1 to 1000 nanometers. Milk is a common colloid. Inside the milk, at the microscopic level, we will find large fat globules and small protein assemblies called casein micelles. dispersed in water. In labs, colloids containing synthetic nanoparticles of various shapes and chemical compositions are routinely made. These nanoparticles gain new properties due to their small size. For example, some properties emit beautiful fluorescence under ultrasonic lights. Nowadays, scientists are interested in using nanoparticles as basic building blocks to create larger structures. Though, through self-assembly, scientists hope to create new functional materials from nanoparticles. To control the final structures, scientists recently have attached DNA single strands on nanoparticles to guide their self-assembly. One day, these new materials made of nanoparticles may find their application in the electrical and optical devices. Thank you. Stay safe, stay happy.